Before there were planets, solar systems, stars, galaxies, there was nothing. And then, the Big Bang. After the first few billionths of a second, everything was still packed together extremely close and very dense. Now imagine every Utah State student down on the court of the spectrum having a dance party. The mosh pit would be very hot and there would be a lot of energy in a very small place. If you were there jumping around, it would be very difficult not to bump into anyone else. The energy each of you had would be getting transferred all over the place, and as a result, you would be getting knocked around, like popcorn in a frying pan.
Now, these two athletic dudes represent photons. For this example, we're going to imagine there are only 2 photons in the universe at this point. Of course, since photons are light particles, this would be very dark, but that would make a boring video. We'll just let it be light for this example. Photons, since they don't have mass, can move around at the speed of light. Sooner or later, these 2 photons would collide. And if they collide with energy that is greater than twice the mass energy of an electron, due to Einstein's formula demonstrating the equivalence of mass and energy, E equals mc squared, they gain mass and become electrons.
They gain mass, which is represented by the extra clothes and pattern. They are now a matter-antimatter particle pair. One of them becomes an electron, and one becomes an anti-electron. The electron is negatively charged. The anti-electron is positively charged. Since one is positive and one is negative, they cancel each other out. Just like when they were photons, eventually they are likely to collide, and when they do, I came in like a rainbow. I never hit so hard. They perfectly annihilate each other and their mass is lost. They turn back into normal photons and they can move around at the speed of light again.
Think of it as a simple math equation. They cancel each other out perfectly.
So, the total time frame of this period of particle creation and annihilation was extremely small, from 1 billionth of a second to 1 millionth of a second after the creation of the universe.
Thanks to the state of matter, at the end of this brief snapshot of time, photons became the main form of energy in the universe. Because of that, we can see the world around us with our eyes.
How do we know this happened? Thanks to the work done by scientists in particle accelerators, most notably the Large Hadron Collider. They are able to accelerate protons to high enough speeds that they can recreate some of these reactions. But why does this cycle of particle creation and annihilation matter?
Scientists estimate there were approximately 1 billion and 1 matter particles for every 1 billion antimatter particles at the end of the particle era. Thanks to that, we have matter, aka everything ever. Keep moving, Trevor. Run, big circles.